Kia ora. More exponential differentiation problems. Example 1. Differentiate e to the power of x times by 2x plus 1. So what we should have identified here is that this is a product of two functions. Therefore, we need to use the product rule. If we identify f of x as e to the power of x and g of x as 2x plus 1, then we can differentiate and get f dashed of x. And we have learnt that the derivative of e to the power of x is just e to the power of x. If we differentiate g of x, so 2x plus 1, then g dashed of x is just going to be 2. Then we're just using the product rule, f dashed of g times g dashed of f. And if we have a look there, we're just looking at substituting in f dashed of x is e to the power of x, g of x is 2x plus 1, g dashed of x, we've got ourselves 2 times by f of x, which is e to the power of x. You may identify there as a common factor of e to the power of x, so we could factorise that out, and then that would give us, in brackets, 2x plus 1 plus 2. So then simplifying, we're going to have e to the power of x times by 2x plus 3 in brackets. Example 2. Differentiate e to the power of 3x divided by 2x squared plus 3. So hopefully when we look at this, we can see that we're going to need to use the quotient rule because we've got one function divided by another function. So firstly, we're just identifying the formula. Remember, these are on your formula sheet. And then substituting in. So if we just put in there, so we've got f of x is on the top line, g of x on the bottom line. So g of x all squared, we've just substituted in there. And then looking on the top line, so f dashed of x, that's going to be 3e to the power of 3x times g of x, so 2x squared plus 3, and then minus g dashed of x, so the derivative of 2x squared plus 3 will be 4x, times by f of x, which is e to the power of 3x. We can look to simplify, and we could see that there's a common factor of e to the power of 3x on the top line, so you could pull that out, times by 6x squared minus 4x plus 9 on the top line. And there you have it. So what I'll get you to do is to work on exercise 15.10 on page 278, and every second question should do there. All right, thank you.